Okay guys, I'm experimenting with you. I've got a brand new tablet and I've never used it before, so we're going to give this a try. Our opening thing is about arithmetic sequences. So you can see this first four terms of an arithmetic sequence are 3, 5, 11, 15. So you can pretty easily see that, this thing is going up 4 and it's going up 4 and then going up 4, etc. So the next term would be up another 4, would be 19, then 23, then 27, then 31. And so now we're all the way at our 8th term. So our 8th term is pretty obviously 31. But what if you get down to here? What if you're having to calculate your 50th term? That'd be really annoying to have to do this whole process. So let's think about what's just happened. And I'm going to see if I can show us kind of the pattern that's been taking place here. So I'm going to kind of change this up just a little bit and come over here. And we're going to create kind of a little table going on with this. I think I just hit a button. So anyway, this is going to be the term number, and this is going to be the term. So the first term was a 3. The second term was 11. The third term was 11. Term 15. The fifth term, ninth term was 23. The seventh term was 27, and the 8th term was 31. Okay, so obviously every one of these things went up 4 every single time. That difference from one to the next. So if we were to do 7 minus 3 equals 4, and then the next term minus the term before it is 4, and 15 minus 11 equals 4. So anytime you do minus previous term, that difference in this case was 4. So now what's the nth term of the sequence? Well, the nth term, first of all, a little notation. The nth term, we're going to use u sub n for our term. The first term would be u sub 1, u sub 2. So this would kind of be like u sub 1, u sub 2, u sub 3, u sub 4, etc. But anyway, and obviously this whole thing starts with a 3. And then we're going to add 4. Well, how many times are we adding 4? Well, to get to this term, we're 1 time. To get to the second term, we added it 1 time. To get to the third term, we added 4 2 times. To get to the fourth term, we added 4 3 times. So we've added a total of 3 times. By the time we got to the 5th term, we will have added 4 again here. So we've added 4 a total of 4 times. Well, what do we notice between the number of times we've added 4 and the term number? It's always 1 less, right? So, to add 4 multiple times, what you're really doing is multiplying. But rather than multiply by 50, I would want to multiply by 49 because you're only adding it 49 times to get to the 50th term. We write that with an n minus 1. So this would be our general formula. If we were to write that kind of really more specifically, it would look like this. An overall formula, the nth term equals term plus d, which is the common difference, times n minus 1, and n is the number of terms that you have. So there's the general formula that we need to know, and that's actually on your formula sheet. Okay? This would be our answer for what is the nth term in the sequence. So this would be for part C. So now for the 50th term, what we would do is we would just start this out. U sub 50 equals first term plus 4 times, and I just plug in 50 for where that n would go. And I just simplify this. 50 minus 1 is 49 times 4 plus 3. So this would equal 199. Wow, there was just lightning right outside the window. If I just jumped, that was why. Okay, so I'm going to attempt to erase all of this. Don't know how to clear the whole thing, so I kind of got to go over everything. The only thing I'm going to keep is this original formula here. So let's see if I can get all of this out of the way. If somebody knows how to erase all of this at one time, shoot me an email or something like that and let me know, because I am learning everything as I go along here. Okay? So, number 2. The first term of an arithmetic sequence is negative 12. The 9th term is 16. What's the value of the common difference? So got to come back up here. I know that the first term is negative 12. I know the 9th term is 16. I don't know the common difference, but I do know the number of terms. There's 9 of them. So I'm just going to solve this equation. Move the 12 over, and this would be 8d. So I'm going to divide by 8, and the common difference would equal 3.5. So every time it's going to go up by 3.5. Okay? All right, let's scroll down here, and let's take a look at this next one, number 3. We're going to do 2 more together here. Okay? The nth term of an arithmetic sequence is u sub n equals 42 minus 3n. What are the values of the first 2 terms of this sequence? So, for the first term, for u sub 1, I'm just going to plug 1 into this. 42 minus 3 times 1, which would be 39. And then the next one, the second term, u sub 2, 42 minus 3 times 2, which would be 36. So, there's my first 2 terms. How much is it going down each time? Okay? 36 minus 39 equals negative 3. And you can see that negative 3 right there. That is my common difference. So, my general formula, u sub n, would equal the first term, 39, plus, or I could do minus, negative 3, and minus 1. So what term in the sequence is negative 9? Well, let's plug negative 9 in as this, and what I'm going to solve for is n. So, n minus 1. I could distribute. Well, that was supposed to be a plus right there. So, 39 minus 3n plus 3. So this would be, you know what I could do? I could have used that formula. I also could have just used the original formula and said I'm going to plug in negative 9 equals 42 minus 3n and move that one over. So this would be negative 51 equals negative 3n, and then divide by negative 3, and n would equal 17. So that's the term of the sequence. Negative 9 is the 17th term in the sequence. How about these 2 consecutive terms? Okay, I'm going to see if I can switch colors here. Just to do this. Well, this is the k term and the k plus 1 term. Well, literally all I'd have to do is plug those things in for n. So u sub k would be 42 minus 3 times k. And then the next one would be 42 minus 3 times k plus 1. And I know if I add those together, it equals 33. So let's kind of work this out. This would be, if I add everything together, this would be 84 minus 3k. Well, this one I should distribute. So this would be negative 3k plus 3. So that 3k and that 3k would actually be, well, let's bring that down, plus 3. So I'm at 87 minus 6k equals 33. Okay? So we're going to subtract this from the other side, and we're going to get negative 6k equals 33 minus, that's 54, so negative 54. So I'm going to divide and divide to be 54. So k would equal 9. So there's our answer. Let's go one more. We're going to skip down to number 5. I want you to come back to number 4, but down on number 5, okay, here's a finite sequence, etc. What's the common difference? Well, again, how much is this going up every time? Okay, that's pretty obvious. You can do that in your head. The common difference is 4. What's the 13th term? Well, my general formula would be u sub n equals first term plus the common difference times n minus 1. So what's the 13th term? So what's u sub 13? Negative 5 plus 4 times 13 minus 1. So that's negative 5 plus 48, which would be 43, would be my 13th term. Okay? And finally, let's see if I can get this thing all the way over here. And so how many terms are in the sequence? So I want to go with 75 being my last number. My first term is negative 5. I'm going up 4, n minus 1, and I'm trying to solve for n. Okay? So again, everything is coming back to this general formula of u sub n equals u sub 1. So the last term equals the first term plus the common difference, number of terms minus 1. Okay? So if I come back over here, I'm at 4n minus 4 with a negative 5 there. So this would be negative 9 minus 4n equals 75. 75 equals that. I'm going to add that. That's 84 equals, that should be plus 4n. Divide by the 4, and 21 equals n. So there are 21 terms in that sequence. All right, so I've done 4 of them for you. Your job is to do the rest of the page. Good luck, and reach out if you have any questions.